Okay, welcome to Chapter 9. We're in the second part of the third phase being the system design phase. Okay, so I'm not going to go into all of the details in this chapter. There's parts of this chapter which, quite frankly, kind of get lost in the weeds and be better suited for somebody who's taking like the CIS401 class about database design. So I am going to skip some of the content, and I'll be very specific about what I'm going to include and not include and what is and isn't going to be on the test. So just kind of pay attention for the cues there. Okay, on page 346, let's go over the chapter objectives, make sure we got everything. Explain file-oriented systems and how they differ from the traditional database management systems. Explain how the data terminology such as what's an entity, what's a record, what's a row, what's a table, those kinds of things. Describe the data relationships, draw entity relationship diagrams, define cardinality, and use cardinality notation. Explain the concepts of normalization. Explain the importance of codes. What's data warehousing, what's data mining, those kinds of things. Differentiate between logical and physical storage. And explain data control measures. So, as always, that little preview case on the next page, on page 347, is pretty doggone cool. I kind of like it. And let's jump right into page 348, talking about data structures. Now, data structures is a term that if you were, in fact, we even have a class, entire semester-long class called data structures. And in that context, we're talking about programming and things of that nature. That is not what we're talking about here. So we have two different terms. And they're talking about data structures, being the framework for organizing, storing, and managing data. That's all. So they talk about data can be either in files or they can be in tables. And they kind of make a distinction about how that part works. So there's a cool little example here where they talk about this auto mechanic shop. In this particular case, we have two files. Now, the files could be, Excel files. They could be text files. They could be, practically anything. But in this particular case, they're not really a database. So the actual format of the files is not really relevant. That's not what we're talking about. We're talking about how they're organized and how they're maintained. So in this particular case, we have two separate files. We have a mechanic file and a job file. And Robert Lear worked on this guy's car. And this works pretty nicely until Robert Lear perhaps gets fired. And you want to take him out of the database. Then you have all sorts of strange things that can happen because he exists in one field but doesn't exist in another. And the alternative is this table-based system, which is I have a mechanic table and a job table, and they're connected together so that if I modify one, it automatically updates everything else. There's an example that I'm sure you've probably run across. How many people have, gotten like two catalogs in the mail or two magazines, identical catalogs or identical magazines, and you look at it and go, why did I get two of these? And you realize that, the name is spelled just slightly different on each one of the catalogs. Probably what happened is they have like a billing department with a separate file and a publishing department that actually sends those things out, and they have a slightly different file. So you called them on the phone and said, oh, by the way, let's say for example you changed your last name. So I changed my last name, and so they updated it over here, but they did not update it over here, and so you end up getting two magazines, one with your old name, one with your new name. Now that only exists if you have a poor database design, or in the case of file-based system, no database design. So we're going to talk about those concepts in a lot more detail. Okay, so I'm not going to go into details of that particular example, but you can read that about, they rely on two files and blah, 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 blah. Okie dokie. There's some comments on page 350 talking about the advantages and disadvantages between file-based and relational database-based. That sounded kind of strange, didn't it? So they ask a question, is file-based processing still being used? Well, there could be some specialized use for file-based processing, yes. In one sense, you could have some specialized software that just zips through some data and does some magic to it, and it could be used to kind of feed a real honest-to-God database. So it's sort of like an intermediary step. Let's say, for example, that you have data that comes from a machine, and it's just a file. And you want to take that and put it into a database. Well, you're using file-based technology, but you're only temporarily and only long enough to get it into a database. So let's say, I don't know, something like your GPS system is recording a log of where you're going. Well, it's not going to produce a database. It's not going to produce a table. It's going to produce text, a file. So you take that file and you look at it and you go, well, I guess I could throw this in Microsoft Access or Microsoft Excel or something, but normally what you would do is you would transport it from its file-based form into an honest-to-God real record, so you can go in there and say, what was the average speed here, or all those kind of things. So yes, it is still being used, but usually is a transition. Okay. And of course, the database environment, they talk about, it's a database management system typically, and a collection of tools, features, and interfaces, and we'll get into that in a little more detail. So let's talk about, the advantages on file-based are relatively few and far between, but the advantages for using a relational database is significant. So you talk about scalability. Yes, I can add more records to a database, and it really doesn't do that much to me. It might slow down my query a little bit, but not by much. Databases are powerful enough that if you build it right the first time, adding additional data rarely has a significant impact. And there's what they call the economies of scale, where the next increment to make it go a little bit more is not all that expensive. Yes, the first part might be expensive, but to add another disk or add some more memory, to get a little bit more capacity, costs less. So it actually costs less and less and less to add additional capacity. So that's kind of cool. And of course, it uses this enterprise-wide application. A database administrator can look at the entire database of an entire company. So that's kind of cool. And it has very strong standards. And you guys remember like the Y2K issue where people had dates stored in a database that didn't have the right number of digits, and oh my God, the world was going to come to an end, when the year 2000 popped up. So databases for the longest time have had adhered to particular standards for like storing dates. And if you had a flat file system, well, you were just screwed, because that GPS unit may use 4 digits or it may use 2, and you didn't have any way to influence how many digits were involved. But in a database, I can say I want to store that in this format. So it's kind of cool. Better security, obviously, with a file-based system, there's no real controls on who can read and write to data. But with a real database, I can say, you can read this table, but you can only write to that one, things of that nature. It's kind of cool. Data dependence. The real thing is, there's a significant difference between where the application and the database, how tightly they're tied together. So, in a file-based system, let's say, for example, roll the clock back 20 years, and you had 5-digit zip codes, and you had a program that read this file, and the zip code was starting at column, 100, and it went to 107, and after that was some other information in this data, and then zip plus 5 came out, and so now I need 9 or 10 digits wide for a zip code. And so I go to the file and I add the extra width on there, and my application crashes because there's an extraordinarily tight relationship between the application that reads that file and the file format. They are linked together. They are married. You cannot change one without the other. Now contrast that to a database where I can go in and change the width of a database field, and the application goes, huh, what? Doesn't know anything about it. Doesn't even care. Now admittedly you might have to go in and make the input box bigger so you can type more information easier, but it will not crash. So that's the kind of cool point, and kind of sort of sounds like a test question, don't you think? Okay, so this data independence issue, that how tightly things are controlled, is a big deal. Okay, another one is the issue of data integrity, and it kind of, I'll talk about it here, but we'll amplify it here in just a moment. And that is the issue of, the billing department having your address, and the shipping department for the magazines, the publication department having your address, and no one notices the address is identical but has two different spellings of your name. That's bad. That's a problem where data integrity didn't work. That you made a change to your name in one table and it did not go through and make those changes elsewhere. So data integrity is a big one as well. Okay, so on page 351 they talk about the components of a database management system, and basically there's three pieces, or three users, so to speak. You have the database administrators. These are of course the guys who run the whole system. You have the users, which is just whoever's been authorized to be able to get in there and do things. And then some sort of related database systems. You could have a database that points to another database, as an example. So those are the three kinds of users, or three kinds of interfaces, or components as they call them. Alrighty, on page 353 they talk about some terms that are appropriate when you're talking about these components. So let's kind of go through them. Structured query language, SQL, has three subparts to it. One of them is called the data manipulation language, DML. And when you're manipulating data, that means I'm retrieving, or I'm updating, I'm deleting, I'm doing something to the data. So that's where most people talk about SQL. That's the portion of SQL that they're talking about, the ability to update something, delete something, insert something, those kinds of things. So that's the language by which these things take place. The next one is this term called schema. And schema is sort of like a recipe or a description or blueprint or some sort of a term that basically means it completely describes the entire layout of the database. And the cool part about a schema, which is not necessarily in the book, is most schemas are written in a form that you can use to recreate the database. So for example, I have this database. It's got, 70 something tables in it. And the tie of all the tables is rather complex. And I'll have customers that say, I'm getting ready to fire one of these things up, but I don't want to type all that. So I just pull a schema off of my existing working database and ship that off to them as a script. And all they have to do is run the script, and it will build all the tables, all the relationships, all the primary keys, everything, all the constraints. Not the data. It's not going to include the data, but it's going to be used as a recipe to build the database. That's one of the cool things that a schema can do. So schemas are good for documenting, and they're also used for creating a duplicate copy someplace else. Okay, we're coming up on the 15-minute mark, so let me just stop here and we'll pick this up again in just a few.